Okay, let's get into class. So this is for distance only, and don't worry, you're not getting double the stuff. What you have to do today, this Wednesday, versus what you have to do on Thursday, Friday is total about the amount of time people will be in class. So this should not take you too long. We are going to learn about something called molar mass, but before we get into that, we just need to think about using words as numbers. So we have this thing, we have a dozen that we talk about all the time. We all know it's 12. And here's a question for you. Why do we use one dozen? Why do you think it works out for us? So take a second, put your answer in. Right. So what we really should be seeing here is it's easily divisible, right? So when we have 12, it's enough for a week if you want to eat some eggs. Each person could get 3. Each person could get 2. People could get 6. You can split it up. You can also split it into 4s. Here's a group of 4, group of 4, group of 4. 12 is a nice number to do lots of different things with, and it's enough for your eggs for the week, unless you eat a lot of eggs. Okay. So what's going on? Well, today we are working on how to count up compounds and what we do. So let's just make sure we know some vocabulary. When we talk about compounds, we talk about anything that's bonded. So NaCl is a compound. H2O is a compound. And we've been working on some of this vocabulary in class. We're going to keep calling this a compound because remember, sodium ions and chloride ions make this lattice structure over and over. So when we talk about sodium chloride, we're never just saying, hey, it's one sodium ion and one chloride ion. It's this whole lattice structure that we build up versus something like H2O, water, that is covalently bonded. It forms these molecules, right? So we have an oxygen bonded to 2 hydrogens. It will be attracted to other water molecules via hydrogen bonding, right? But it doesn't make the same lattice, right? These are their own discrete things, but they're both called compounds, okay? But we do have to think about this being a unit. So that's what we'll be discussing for ionic compounds like that. Then after this, you have a set of practice problems. It should take you maybe 20 minutes, okay? Not a big deal. So let's keep moving on. Again, we're talking about this all week. This is our chemistry math unit. I know it makes some people freak out, but don't. This is going to be safe. We're going to help you with some things. If you've always struggled with conversions, we're going to help you practice that and make sure you feel good because that's just a life skill, okay? So just letting you know it's going to be okay. All right. So let's just do a couple of practice things just from what we've learned this week, just to make sure we're feeling good. So we have some things here, and notice we're being given everything in moles, and they're asking for how many things. So how you want to start thinking about this is, what is your conversion factor? What are things you know are equal? Well, we know that 1 mole is equal to 6.022 times 10 to the 23rd things. Just like how we talk about 1 dozen is equal to 12. Okay, it's just a much bigger number, but we're not going to let it freak us out. So we want to know how many atoms are in 1 mole of carbon-12. Well, you might be saying, Ms. Brown, I know exactly the answer, and that's fine. But just to make sure, we're going to use our conversion factor. We know that 1 mole is equal to 6.022 times 10 to the 23rd, right? So we will, and this is things. In our case, this is going to be atoms. So 1 mole divided by 1 mole, right? Because this is in the denominator, multiplied by 6.022 times 10 to the 23rd, we get 6.022 times 10 to the 23rd atoms of carbon. Okay. Now, 2 moles of H2O molecules, well, we just have the same thing set up, right? For every 1 mole, we have 6.022 times 10 to the 23rd thing. So if that's how much is in 1, we're going to multiply this by 2, right? So moles are going to cancel. 2 times 6.022 times 10 to the 23rd, 1.244 times 10 to the 24th, right? I just did that in my head. I hope it's right. Okay, I should grab my calculator. So that's what we've got going on there. Okay, let's keep moving. 3 moles of donuts. Oh, that sounds good. It's Sunday morning here, and that sounds great. It's the same setup, right? 6.022 times 10 to the 23rd. Why don't you give me an answer? Tell me what you got. Okay, I'm getting 1.8066. Oh, I think this should be a 0 there. Yep, it should. Is that right? Nope. that's wrong. Okay. 1.8066 times 10 to the 24th. Let me double check this answer. Yeah, there is a 0 there. Okay. Sorry. That's what you should have gotten. Okay. And then this is how many donuts you have. Nice. Okay. So not too shabby. I think I'm just going to cut that. Okay, let's look at the second problem. Okay, so similar setup. And sometimes people want to put 2's down here. Don't do that. You got to put what's equal. This is your conversion factor. Okay, so we're talking about 10 to the 23rd molecules are our particles here. Okay, so 2 multiplied by 6.022 times 10 to the 23rd molecules. Moles are going to cancel. We end up with 1.2044 times 10 to the 24th molecules of water. All right, let's do the last one. Okay, so let's do the setup, and then I'm going to have you enter the answer on your own. So it's the same thing. We're just talking about donuts this time in 1 mole. Okay, so the moles are going to cancel, right? And tell me what you got. Okay, I got this. A lot of donuts. More donuts than our planet could actually create. Okay, hope that's doing okay for you. Let's keep going. Let's just do a few more. Ooh, okay, so get out your periodic table. How many grams are in 1 mole of carbon? And my numbers might be slightly different than yours. I'm using a different periodic table than what I sent you home with, because that's what I have at my house. So grams in 1 mole of carbon. So we're going to go to our periodic table, right? What'd you get? Okay, I got this. 12.01 grams of carbon. Okay, try the same thing with lithium now. Okay, lithium. Okay, so you should be taking the number from the periodic table, because that is how many grams are in 1 mole. It's also how many AMUs are in 1 atom, right? We have both of those. It works for both because chemists were smart when they did that. Okay, how about in 2 moles of lithium? Okay, so think about, what are you going to do? What mathematically needs to happen to this number to get how many are in 2 moles? Okay, so remember, what we need to do here is we're going to say 2 moles. I'm just going to write this out. You don't necessarily have to do that. But in every 1 mole, we have 6.94 grams, okay? So we're going to see the moles cancel. We're going to have 2 multiplied by 6.94. Okay, and I got 13.88 grams of lithium. Do make sure you have to have that grams on there. You got to be labeling things. Okay, how many molecules are in 1 mole of ammonia? Oh, do we even know what ammonia is? Does it matter? No, it doesn't matter. For fun, ammonia is NH3. Okay, 1 mole. How many things are in 1 mole? Do you know how many things are in 1 mole? I hope so. How many things in 1 mole? So this is kind of a vocab question. Okay, how many atoms are in 1 mole of hydrogen gas? Okay, this is tricky. I'm going to have you guess right now. Get in an answer. Okay, don't forget hydrogen gas is H2, which means there are 1 mole of molecules. Okay, so each molecule is an H bonded to another H. So there's 6.022 times 10 to the 23rd of those. But there are 2 atoms in every molecule. So we are going to end up doubling this because there are 2 atoms in every 1 molecule. So we get 1.2044 times 10 to the 24th atoms. That was the challenge problem. Okay, good. I hope these are going okay. Let's keep going. Let's try some harder ones. How many grams are in 2.5 moles of aluminum? Okay, so start with what you're given always. Okay. Oops. Okay. Come on. Okay, so 2.5 moles. We need to figure out how many grams are in that. So what we need to do is we need to say, okay, for every 1 mole, how many grams are there in aluminum? So go to your periodic table, look at aluminum, find the molar mass. Okay, so the mass is 26.98 grams of aluminum in every 1 mole. Okay, so look at how we have it set up. Moles are going to cancel. 2.5 multiplied by 26.98. Okay, so that makes sense because every mole weighs 26.98 grams. We have 2.5 of them. So it makes sense that our number is 67.45 grams. Okay, let's do it the other way. So we're going to start with 38.4 grams of copper. So we need to go to our periodic table, figure out how many grams are in 1 mole to convert this, okay? So find copper. Copper's number 29. Okay, I got 63.55 grams in every mole. So let's just think about this. Do we have enough to make 1 mole? No, we don't. So we're expecting this to be a number less than 1. So what we do, we take this number, divide by this number in the denominator, multiply by 1, which is also just doing nothing. Okay, so 38.4 divided by 63.55. I got 0.604, and really we should only use 3 numbers. Okay, so 0.604 moles of copper. Okay, so let's keep going. Let's start thinking about compounds. So can you have a mole of a compound? Can you have a mole of ammonia? Can you have a mole of water? Sure, you definitely can. Okay, it just takes this up the next level. So how do we determine the mass of these things? Okay, so let's think about this. All you need to do is you take the mass of each atom that is in it. Okay, so we would add up the mass of 2 hydrogens and the mass of 1 oxygen to get the mass of the overall compound. Okay, so it's pretty straightforward. We're literally just going to add them all up. We're going to go from there. So hydrogen, each hydrogen, we have 2 hydrogens. So 1 hydrogen is 0.1008. The other one is 1.008. The oxygen has a mass of 16.00. Again, your numbers might be slightly different. So we just need to add this up, right? So this is a 6. This is a 1. You obviously can do this on a calculator. So I got 18.06 grams per mole. Or remember, this is AMUs per atom. Okay, this is the number we're going to use the most. So if you have 1 mole of water, it has a mass of 18.016 grams. Okay, so let's practice this. Let's see how it goes. So determine the number of grams in 1 mole of each of the following compounds. Okay, so we'll do ammonia together, and then you'll do the next 2 on your own. So what you need to do, you need to take the mass of 1 nitrogen, which is 14.01, because remember, there's no number down here. So it just means we have 1 nitrogen, okay? Now we have 3 hydrogens. So we're going to add 3 times whatever the mass of hydrogen is. Okay? Add those all together. Okay? And what are we getting? Let's take it. 3 multiplied by 1.008 plus 14.01. Okay, I'm getting 17.034. Okay, and we should chop it off there. So 17.03 grams in 1 mole. All right, so do methane on your own. See what you get. Okay, I got that methane was 16.042 grams for every mole. Now, magnesium hydroxide, this one's tough. Okay, remember when the 2 out here is outside the parentheses, it means we have a magnesium and a hydroxide and another hydroxide, okay? So see what you do, add those up. So I'm getting that magnesium is 24.30, 2 oxygens is 32.00, 2 hydrogens is 1.016. Okay, so we'll just add all those up. So what am I getting? I'm getting 6. Wait, nope, are those aligned? 6, okay, 1, 3, 7, 5. Okay, so 57.32 grams in every 1 mole. Okay, so that's how you do those. That's how you get the mass of a compound, the molar mass, meaning how many grams are in 1 mole. So let's use this using the same math we did before. Let's see how this goes. So how many grams are in 1 mole? Okay, remember, this is O2. Okay. How many grams are in 1 mole of oxygen gas? Okay, this is pretty easy because we're just talking about 1 mole. So this is from the periodic table. So what we need to do is we need to figure out what the molar mass of oxygen gas is. So go up to your periodic table. We need 2 oxygens. So you're going to add those two 16s together. We get 32.00 grams in every 1 mole. Okay. Just straight from the periodic table. Ooh, now things are going to get a little bit tougher. First, let's figure out the molar mass of copper 2 chloride. So how many grams are in 1 mole of copper 2 chloride? Well, we have 1 copper. Okay. And we have 2 chlorines. So get a number. Add it all together. Okay, I got that the mass of this is 134.45. So don't forget, this is how many grams are in 1 mole. Okay, so now what we need to do is we need to figure out how many moles are in this. So 352 grams. We're going to see how many times 134.45 grams goes into that to determine the number of moles, right? So how many times does 134? At least twice, right? So you take 352, divide by 134.45, okay? And I got that that is 2.62 moles of copper 2 chloride. Okay, let's do this one. Ooh, okay. Give this one a shot on your own. See how you do. See if you get the right numbers. Okay. Okay, so I got that the mass of this was 101.96 grams for every 1 mole. Okay, we're going to start with 4.56 moles. Okay, this is how many grams are in 1. So we need to multiply that by 4.56, right? So for every 1 mole, we have 101.96 grams. So we're expecting somewhere in the 450 range, right? So 4.56 multiplied by 101, I got 464.94 grams. Okay. Any questions? How are you feeling? You're going to go practice this on the practice problems. I'll let you ask a question here or shoot me an email if you feel stuck or lost. Nice job, everybody.